All right, we're on page 567, and let's look at these first six. This isn't finding x or anything like that. It's simply an exercise in, do I know these definitions of these trigonometric ratios? If I know the definitions of the trig ratios, these problems are easy. If I don't know the definitions of the trig ratios, these problems are very, very difficult. So for number one, we want the sine of A. So I look at my triangle over here. There's point A. Sine of A equals opposite over hypotenuse. So which of those numbers, the 20, the 16, or the 12, is the length of the opposite leg? And what's the hypotenuse? 20. Now, if you want to reduce that, you can. I don't care if you do or not. Okay? Number two, the tangent of C. All right, so look, not only are we changing the trig ratio, we're changing the point, the angle that we're using. Now we're at C. Tangent is opposite over adjacent. So the tangent of C would be 12 over 16, not 16 over 12. 12 is opposite, 16 is adjacent. All right, number three, the cosine of A. So we're back to A. Cosine is adjacent over hypotenuse. The adjacent leg is 12. The hypotenuse is 20. Make sense? All right. Do 4, 5, and 6. Did you get what I got? All right, so you've got to know the trig ratios. You've got to know them. And you've got to remember, to focus on the correct vertex. If it's the tangent of A, you got to go from there to figure out what's opposite, what's adjacent, what's hypotenuse. When it's C, you got to use that one to figure out what's opposite, adjacent, and hypotenuse. So we're good on the first six. All right, number 7. Use a special right triangle to express the sine of 60 as a fraction, and you can do the decimal if you want. All right, special right triangle. Well, the special right triangle that we know of that has a 60 degrees in it is a 30, 60, 90. Now, like we did yesterday with the 45, 45, 90, I made this triangle. I get to decide what the lengths are. However, the short leg, the hypotenuse has to equal the short leg times 2, and the long leg has to equal the short leg times the square root of 3. But I get to choose what the length of the short leg is. So I'm going to choose 1 because 1's easy to work with. If I choose the length of the short leg to be 1, the length of the long leg is short leg times the square root of 3. So what's the length of the long leg? Square root of 3. So I'll put that here. And the hypotenuse equals the short leg times 2. So what's the hypotenuse? 2. All right, now, they want us to express the sine of 60. So there's my 60. That's the vertex of the 60-degree angle. So the sine of 60 equals opposite. What's opposite? Square root of 3 over hypotenuse, 2. That's it. All right. We okay with that? Number 8. Find x, round to the nearest hundredth. All right, so that's the vertex of the angle that we know. So that's the vertex of the 52 degrees. Now look what we have. We're looking for the opposite leg, and we know the adjacent leg. So which one of our trig ratios equals opposite over adjacent? Tangent. So we're going to use tangent. So we're going to write that the tangent of the angle, so the tangent of 52, equals the length of the opposite leg, x, over the length of the adjacent leg, 13. So we've got an equation. That's always helpful if you're finding x, right? To have an equation. So we've got an equation. Let's get rid of the fraction. The way you get rid of the fraction, and we talked about this yesterday, is you multiply both sides by the denominator of the fraction. So 13 times the left side equals 13 times the right side. And we got fortunate because not only did that get rid of the fraction, it also got x all by itself. So we've actually solved it for x at this point. But now we need to simplify our answer. So we get out our calculator. No. Let me address. All right. So make sure you're in degree. Okay, I am, so I'm good. So 13, I don't even have to use the times button. The calculator knows. It means times the tangent of 52. And so I get, so I get 16.64 when I round it to the nearest hundred. All right, I had a good question. Could you multiply the 52 times the 13 and then take the tangent of that? No. I'll show you. But here's the reason you can't, is because the tangent of 52 is a number. I don't know what it is, but it's a number. Just kind of like, the square root of 3 is a number, and we've just got to treat it like a number because it is a number. I don't know what the tangent of 52 is, but it's a number that never changes. It's a constant. So look what happens. So let me do that first. So look, that's what the tangent of 52 is, and then multiply that by 13, and that gets us the same answer, doesn't it? So that works. And if I multiply 52 times 13 and get that, and then take the tangent of 676, nowhere near the same thing. Okay? So, doesn't work that way. We're okay with number 8? Number 9. All right. We've got the 61 degrees. There's the vertex of the 61 degrees. I need to write an equation with x in it. Do I want to use sine, cosine, or tangent? If I use the sine of 61, that equals opposite. What's opposite? 24 over hypotenuse, x. So multiply both sides by x to clear fractions. So x times the sine of 61 equals, multiply x times the right, just get 24. Now, we did not get x all by itself. Okay, so it requires another step. What do I do to get x all by itself? Yeah, and then to get rid of the sine of 61, the sine of 61 is times the x, so you undo multiplying by x by dividing, or multiplying by the sine of 61 by dividing by the sine of 61. So x is going to equal 24 divided by the sine of 61. And we need our calculator again. So x is going to equal 24 divided by sine 61. And we get 27.44 to the nearest hundredth. Everybody following me? Making sense? All right. See what you can do with number 10. Anybody else get 16.93? Did you use sine, cosine, or tangent? Cosine. We use the cosine of 27 equals adjacent. What's adjacent? X over hypotenuse. Is that the way you had it set up? All right, what do I do next? Multiply both sides by 19. That gets rid of the fractions. So 19 times the cosine of 27 equals x. Hey, that also got x all by itself for us. So we've solved it. Now we need to simplify our answer. So we use our calculator. 19 times the cosine of 27. And we get 16.9, then 29 rounds to 3. So 16.93. You with me? Now, with some practice, you can get really good at these. Okay? But it's going to take practice. Every now and then, you're going to use sine when it should have used cosine or whatever. So, take your time, be careful, get them right. And there's your assignment. On page 567, do 1 through 10, 16 through 33, and 66 through 69.